Hi everyone. So today's problem of the day is maximum distance between a pair of values. So what is given in the description is we are given two non-increasing zero indexed integer arrays nums1 and nums2. A pair of indices ij where I should be greater than or equal to 0 and less than nums1 dot length, or j start from 0 to nums2 dot length less than nums2 dot length is valid if both I is less than equals to j and nums1 of I should be less than equals to nums2 of j. The distance of the pair is j minus I. Return the maximum distance of any valid ij. If there are no valid pair, we can return 0. An array is non-increasing if ARR of I minus 1 should be greater than ARR of j I for every I greater than equals to 1 and less than ARR dot length. So what is given in the problem is like nums1 we have given some array. In some array we have given nums2. And these two nums1 and nums2 are non-increasing. Non-increasing means if there are two values, suppose x and y, and some other values are also there. So this y should be greater than equals to x. This is like the non-increasing. It will be increasing. Sorry, it is non-increasing. That means it will be decreasing, but the value can be same also. So yeah, what we need to do is like we just need to keep in mind that we need to find the distance j minus I, where j should be greater than equals to I होना चाहिए, and nums of j should be greater than equals to nums of I होना चाहिए. Only these three conditions we need to see, that j should be greater than equals to I, and j where we will point at j will be pointing to nums2 and I will be pointing to nums1. I'm going to find j minus I, and nums of j should be greater than equal to nums of I. So if we will try to see with the example, we will run how we can solve it with the example. It will be easily understood with the help of example. If we have nums1 and we have nums2, so we are here 55 and 100. So 55 and 100, this is our I and this is our j pointer. So j should be greater than equals to I होना चाहिए, and j should be greater than I, and nums of j should be greater than equals to nums of I. And we have some answer pointer. Starting में it will be 0. Now we will see कि j is 100 and this is 55. So this is a valid case because 100 will be greater than equals to 55 and 0 greater than equals to 0 because both are pointing to 0. This is a valid case. So we will update our answer. Answer will be equals to 0 comma maximum of 0 comma j minus I. J minus I means 0 minus 0. It will be 0 only. So answer will not change. It will be 0. Now what we will do is like we will move to the next pointer. We are in 20. We are at 20. We will move our if we got the valid answer, so we will move only the j pointer because we need to maximize this j minus I. How we can maximize this j minus I? If our j will be greater than I, so we will move only a j pointer. So j is now at 20. So if j is now at 20 to 20 is not greater than equals to 55. This is not a valid case, so we will move our I pointer here. Now I is here and j is here. Still j is not greater than equals to I. So what we will do, and we will see key this. So we will move both the pointer. Why we are moving both pointers? Because we need j greater than equals to I. If we will move only I pointer, then I will be greater than 0, and we don't need that case. So and we need valid case also, and it is not satisfying this 30 and 20. So we need to move one step towards this. Both we need to move one step, and only in the case where I should be less than j, in that case only we will move I pointer alone. Otherwise we can move both j pointer and I pointer. And if we got some valid answer like nums of j greater than equals to nums of I, then we will move only j pointer only, because we will try to maximize this value j minus I. So now we will move both pointer to 10 and 5. So 10 is greater than 5. So this is a valid answer. So this is j pointer and this is I pointer. This is a valid answer. So we will maximize the answer, but both are at the same index, so it will be 0 only. Now we got the valid answer, so we will move at j only. So j, we will move only j to j. So now 10 and 5, which is also a valid answer, but and j minus I value is 1, so we will update our answer to 1. Now again, this is a valid case, so we only move j. If we will move j to j minus j is greater than equals to 2, this is also a valid case. And so the value of j minus I will be 0, 1, 2, 3, 4, 4 minus 2 to 2. So again, we will maximize our answer. Answer is 2, so we can return at the end answer 2. We'll move to the second example. We are at this index and this index. Now 10 and 2, this is a valid case. Initially answer is 0. This is a valid case, so we will maximize our answer. So answer is 0 only, because j minus I in this case is 0 only. So it is 0. So after this, what we will do is we got the answer in this case. So we will only move j pointer, because we want to maximize our j minus I value. Now we can see is 10 and 2. This is also a valid case. So now in this case, j minus I value is 1. So j answer is now 1. Now again, we will move on the j pointer, because we want to maximize j minus I. But this is not a valid answer, because nums of j is not greater than equals to nums of I. So in this case, what we will do is we will try to increase this until we are at this position. So we will, so we can decrease. No, we don't. We just need to increase it one pointer. So if it is now, it is at g this pointer. So now also this is not a valid case, because nums of j is less than nums of I. So again, it will move one pointer. Again, this is not a valid case, and these both indexes are equal only. We'll move both of our index. It is out of uh, nums 2 or nums 1 length, so we can return our answer. Answer till now is 1, so we can return 1. It's a bit confusing, but we need to only there are two array nums 1 and nums 2. If we will got a valid answer, then we can move only this j plus plus we need to do. If our I is less than j, then we can move only I plus plus. Otherwise, in all case, we will do I plus plus and j plus plus both. Because our j index should be greater than equals to I over j. This is written in the question. And now we are at this and this. Now 25 is less than 30. So we will move both of our pointer. And now this 25 is less than 29. So we will move again this pointer. And then again we will move this pointer, because no, we don't need to move this pointer, because if we will again move this, because I is less than j na, so we will move this pointer only. So we are at this 19. 19 is less than 25, so we got our answer 0, but it is 0 only, so it will not affect. Now we got the valid answer. Then now we will move on the j pointer. Now again 25 is greater than 19. So again it is incremented by 1. Now it will move again to this. So sorry, it is 19 only. We got the valid answer. So we will move this pointer. 25 is now still greater than 19. So we got the answer as 2, because j minus I when I is 2 now. And now again we will move this pointer, but we are out of the array length. We can return our answer. Answer till now is 0, so we can return 0. So constraint given is nums dot length and nums dot 1 dot length and 2 dot length will be greater than equals to 1 and less than equals to 10 to the power 5. And these values should be less than equals to n power 5, and this nums1 and nums2 are non-increasing. So this answer is basically easy only. What we have done, we have declared the nums1 length, nums2 length, I and j pointer. I is pointing to nums1 of I, and j is pointing to nums2 of j. तो अगर अपना nums1 of j I अगर but is greater than आता है, if this value is greater, is we will get greater value, then what we will do is we need this greater value. So we will check one condition. If I is less than j, then we will do only I plus plus. But if I is not less than j, then if our j is greater than equals to I, then we need to increase both, because our j should be greater than equals to I in every case. We will increase both our I and j. In else condition, if nums of I is not greater than equals to nums of j, that means in else condition, when it will go to else condition, when nums2 of j was greater than equals to nums1 of I. So this is a valid case. So in valid case, we will do answer comma j minus I, and we can increment our i's. I we can j we will increment in our valid answer if we will get some valid answer. But if we are not getting any valid answer, then we can check if I is less than j, then we can only increment I. Otherwise, we increment I also and j also, because we need j greater than equals to I in every case. So yeah, that's it. And if you will see the time complexity in this case will be big of n plus m. And if you will see the space complexity, it will be big of 1 only. So yeah, that's it. Thank you.